Okay, let's record topic D, global warming and pollution. So you have energy received from the sun, heats up Earth. Then we have heat radiated from land and sea and oceans. We have greenhouse gases get trapped. We will see all of this. Burning of fossil fuels and power plants emit greenhouse gases, so on. Anyway, outline, two main points, global warming and pollution. Global warming, we'll see how carbon dioxide levels and global warming trends go hand in hand. So we'll talk about recent warming and cooling trends due to the burning of fossil fuels. And we'll present some isotopic evidence for this global warming. In other words, when CO2 levels go up, temperature goes up, and so on. Pollution, talk about ozone, the Montreal Protocol. We talk about fertility rates and population growth and so on. So the first topic, global warming. We said that carbon dioxide levels and global cooling and warming trends. When CO2 levels go up, it's global warming. So we said that Greenland polar ice sheet contains record of the atmospheric temperature, as well as CO2 levels in the atmosphere. What is the evidence? Well, geologists mapped out ocean temperatures and correlated them to carbon dioxide levels over a long geologic past. I'll show you the curves. Warmer oceans, this is for the atmospheric temperature. Warmer oceans are associated with more carbon dioxide outgassing. Fish and marine plankton end up at the ocean bottom. So we said the ice cores from Greenland and deep sea sediment cores contain a time record of atmospheric and ocean temperatures. This is ice core, this is deep sea sediment. Warming pairs are associated with high carbon dioxide levels and vice versa. So the carbon dioxide cycle, let's go over it very quickly. If you remember, topic B was geology. We went over some of this, subduction and so on. So we said that volcanoes emit carbon dioxide, then rain dissolves it. Rock weathering absorbs carbon dioxide. This is the chemical reaction. Calcium oxide plus carbon dioxide gives calcium carbonate. This is a rock. Rivers carry these dissolved rocks to the ocean. A sedimentation in the ocean. And then from there on, it's geology. Subduction melts the rocks. In other words, the plate tectonics. When a plate subducts underneath another one, at really great depths, temperature is high. These rocks melt, gives magma, which becomes lava. Then volcanoes. Lava is emitted by volcanoes. Volcanoes contain a lot of carbon dioxide. They emit carbon dioxide. So that's the carbon dioxide cycle. Okay, so let me show you carbon dioxide levels, concentration in the atmosphere and the relative temperature here. They go hand in hand. When carbon dioxide levels go down, temperature goes down. When carbon dioxide go up, temperature goes up, and so on. This is over the past 400,000 years, ice core from Greenland. Okay, This is even a longer period of time, 100 million years. We said the global temperature dropped by as much as 8 degrees C over the past 100 million years. So this is the temperature here. Went from 23 down to 15, dropped by 8 degrees C over these periods. And the carbon dioxide came down by a factor of 10. Went from 3,000 ppm down to about 400 ppm. Okay? The Cretaceous period is the period of the dinosaurs, so decreasing level of organisms that produced decreasing carbon dioxide level. So from 145 to 65 million years. Cretaceous period. Right here. Okay. So here we're showing again the eras of geologic history. We went over this part B. So we have the Cambrian here. That's 500 million years ago. The Permian is 250 million years ago. This is the era of the vertebrates. From 250 to 65 million years ago, era of the reptiles and birds, including the dinosaurs. If you remember, dinosaurs got extinct 65 million years ago due to the impact of huge meteorite. They died out. And then from 65 million years ago to now, era of the mammals. Okay? And humans have been around for the past million years. 1 million years. Okay, there are many global warming and global cooling trends due to natural concentration, emission of carbon dioxide, and natural dissolving of carbon dioxide by rain. The last one goes back to some 10 to 14 million years ago. The last global cooling. It's the last, okay, was a global cooling that ended about 10 to 14,000 years ago. There you go. Okay. So we said that the mid-Pliocene period, or tertiary period, that's 3.3 to 3 million years, so 2 degree temperature increase on Earth. It's global warming. The Pleistocene epoch, 2 million years ago, 12,000 years ago, was a global cooling. That was a global warming, that's a global cooling. Okay, sea level was some 120 meters below the present level for the global cooling. The coldest period on Earth ended some 12,000 years ago. Okay, let's skip this. Let's skip this. And then isotopic evidence for climate change. Okay, so we know that water boils at 100 degrees C, while heavy water containing deuterium instead of hydrogen boils at a higher temperature at 101.4 degrees C. What does it mean? It means when it's warmer, there is more heavy water moisture in the atmosphere, higher temperature. Okay? So keeping track of isotopic abundances in the Greenland ice sheet keeps track of temperature. Also, there is tiny bubbles trapped in ice. These bubbles contain carbon dioxide level. So measuring the concentration of this carbon dioxide in these bubbles gives us the atmospheric composition as far as carbon dioxide. So we know the depth because we know the layer in the ice sheet. We know the temperature as due to levels of heavy water. And we know the carbon dioxide composition. Okay, this is North Pole, South Pole, they agree, and there is also ocean bottom core that contains seashells and so on. Gives us the carbon dioxide level in the ocean. So second topic is pollution. We said the Environmental Protection Agency issued a list of air pollutants: carbon dioxide, carbon monoxide, sulfur dioxide. Sulfur dioxide is emitted from coal plants. So the Clean Air Act legislation of 1970 mandated the end of leaded gasoline. So that cleaned up vehicle emissions and leaded gasoline. Okay, and coal plants added scrubbers that reduced sulfur dioxide levels. Skip this. Let's talk about ozone. We said the ozone has two effects. One is the stratospheric ozone. Stratosphere is here between 15 and 35 kilometer altitude. That's this one. Stops harmful UV radiation. CFCs used in spray bottles, spray cans, and so on destroyed this ozone layer, destroying it. And there is also the second where we find ozone, ground level ozone, which is emitted by cars and so on. This one is really pollution, source of pollution, harms the health of citizens and so on. We said the ozone has a residence time of decades in the stratosphere and of hours to days in the atmosphere. Hours to days and decades here. Ozone pollution gets worse in the afternoon. There's a traffic, due to traffic, the commute. Okay, so let's skip this one. We said that CFCs in spray cans destroy the ozone molecule. Increases occurrence of skin cancer. So the Montreal Protocol 1987 curbed down the amount of CFCs. So they went down. CFCs got replaced by HCFCs, which do not destroy the ozone layer. Skip this one. Okay, so skip these two. Global changes on Earth. We said tectonic process is powered by Earth's heat engine. Plate tectonics and subduction and so on. And, this in turn drives the rock cycle. In other words, carbon dioxide dissolves in rainwater and it falls, if you remember, the weathering reaction, and creates calcium carbonate and so on. And the rock cycle, CO2 is emitted by volcanoes, and then weathering brings it back, and then subduction and so on, earthquakes. Active tectonics means active volcanoes, which means more CO2 emissions, which increases global warming. A warmer atmosphere means increased evaporation and precipitation in equatorial regions. Okay? So if there's a lot of CO2, rain will decrease it. At the same time, desert regions expand. Hurricanes become more intense when it's warm, global warming. Ice sheets melt and ocean levels rise. This is what we are experiencing right now due to the burning of fossil fuels. Permafrost in the tundra melts, therefore releasing more CO2 and so on. So we see in 1980, Greenland ice sheet was huge and it's been decreasing. Skip this one, skip this one. Okay, This is a satellite survey of CO2 levels around the world. Industrialized nations seem to produce most of the greenhouse gas. Okay, fertility rate and population growth. Fertility rate is the number of children per woman. So in other words, the population has been growing, 1800 first billion. Now there's over between 7 and 8 billion. Higher growth, fertility rate in poor countries, increases due to development of vaccines, better food production. The replacement fertility rate or the population remains stable is 2.3. In the US is close to 4. In some countries it's higher than, close to 2, higher than 4. Okay, population growth predictions. We said that present population in Asia, so this is Asia, this is Africa, this is some of the other nations. So now population in Asia is highest. Around 2050 will level off, start decreasing, level off around 5 and start decreasing. While the population in Africa right now is between around 1 and 2, keep on increasing up to 4 by the end of the century. Population of Africa will be increasing a lot. It will not level off until there is development, until there are democracies, until all of these issues get resolved. I mean, now if Europeans are complaining about boat people coming from Africa to Spain, Italy, and Greece, wait till the end of the century. If there are like 1,000 boat people, now there will be millions of people from Africa going to Europe and so on. All right. Okay, summary: global warming, pollution, population growth. Amount of greenhouse gas in the atmosphere determines the level of global warming cooling trends. There's a lot of CO2, global warming. There's a little bit of CO2, global cooling. There is isotopic evidence of global warming cooling trends caused by natural phenomena in distant past, like volcanic eruptions, so on. There's evidence of multiple global warming cooling trends. Some of them are associated with global extinctions of species and so on. Yeah, the regular rate of species extinction is about 100 per year. Now we're going through 1,000 times that. 100,000 species getting extinct per year. So we said we're experiencing global warming due to the burning of fossil fuels. As far as pollution, we said that legislative measures helped curb down pollution, like the Montreal Protocol banned the use of CFCs. The Clean Air Act mandated the use of scrubbers and plants, reduced pollution. We said population growth between 7 and 8 billion right now. The world population growth has slowed down, might level off and come down. Okay. Thank you.